Chapter 6, Helping Children to Problem Solve. So in Chapter 5, we looked at aspects that help us think about how we deliver problem solving to children, such as connections, communication, reasoning and proof, and representations. In this chapter, we're actually going to be thinking about how the children are problem solving and what they're doing when they're solving problems. The first key idea is to understand is there's two different problem types. One is a problem, two is an exercise. For example, 2 kitty cats plus 3 kitty cats for many children is an exercise. An exercise is a word problem where children immediately know the answer and doesn't require much thinking on their part. Now, there may be a handful of first graders that 2 kitty cats and 3 kitty cats is a problem, but the bulk of the classroom, that's actually an exercise. An example of a problem is a much more difficult problem, such as some children are at the beach. There are 3 pails with 2 rakes and 4 shovels in each. How many tools are there to use for digging in the sand? That's much more of a problem for many children. It's not as clear-cut as 2 kitty cats and 3 kitty cats. So we need to pay attention to the problems we're presenting to children. Frequently in our textbooks or our curriculum, we typically have exercises. They don't ask a lot of critical thinking from the students. So we need to make sure that we are exposing our students to much more difficult problems that require them to think critically. In this same consideration, we need to think about, are we offering routine problems or non-routine problems? A routine problem means that there's pretty much a mathematical process that they already know to solve the problem. A non-routine problem might be an example of a growing pattern. As we look at birds flying through the sky, another example of a non-routine problem might be something like the dinner party problem that you solved the other day. That's not a clear-cut example of there's one algorithm to solve the problem. You ought to think about it and use some strategy to solve that problem. It wasn't like there was cats and dogs and you were clearly adding them together or separating them. So we need to make sure that we have a balance of routine problems and non-routine problems in our problem-solving instruction. When we're considering how to teach mathematics through problem solving, there's a bunch of big ideas we need to be thinking about. First, allow mathematics to be problematic. Children should not always get the correct answer quickly and easily. The process of doing mathematics is working through the progression of thinking that gets you to an answer. If children always get the answer quickly, it means it's too easy. They need a little bit of a challenge, so when the concepts of mathematics get more difficult, they're prepared to sit and think and persevere through a problem, which is our first mathematical practice. Next, we should focus on the process rather than correct answers all the time. Frequently, teachers overemphasize the correct answer and don't really ask how children problem solve. We saw an example of this in the videos the other day, where the student got the correct answer for the completely wrong reasons with fractions. So by actually asking her about her process of thinking about those equivalent fractions, we found out she really didn't understand the mathematics, even though she had the answer correct. Another key thing we need to do as a teacher is to give them the right information at the right time. Let them struggle a little bit and then scaffold that support in and help them through the process. Furthermore, instruction should build on what children already know. You've heard me say this before and you're going to hear me say it again. And another idea, don't wait to problem solve. As I said in the last video, children don't have to have 100% mastery of a concept before we can problem solve. Problem solving can actually help children develop their competence in things such as their math facts. Next, and I've talked about this in the previous video as well, problem-solving achievements are related to developmental levels. We need to pay attention to what level the problems are. If your students are in advanced, then you need to make sure that they have access to the problems that the textbook or you are presenting. On the flip side, if the problems are too easy, you need to make sure you increase that difficulty to meet the demands of the child for where they are at. So when considering appropriate problems, I'll be quite honest, your textbook doesn't have a great offering. Typically, they're much too easy for children. So when you look at problems from the internet or word banks or other resources, here are 3 major questions you need to ask yourself when you're considering your problem selection. Does the problem ask the students to represent mathematical ideas in various ways? It gets back to that idea, is it actually a problem or is it an exercise? Does the problem ask students to investigate numeric or geometric concepts? Does the problem actually get at the mathematics? Are the children going to get hung up in the words and never get to the math? It's something you need to consider as a teacher. And lastly, does the problem require estimation or should the mathematics be exact? Sometimes children are working through the bigger ideas of a problem and an estimation in numbers is more appropriate than having the exact calculations because you want them thinking about the process of it all rather than that correct answer. Jorge Polya developed a plan in the early 60s. This guy's a genius. Prior to his developing and putting out a plan, we talked about problem solving in the world of mathematics, but nobody formalized it. So here it is, plain and simple. He told us that we need to understand the problem, make a plan to solve it, carry out that plan, and look back at your work. Prior to that, there had been lots of suggestions how children need to think about problem solving. I will say you will have many children sitting in your classroom when you put a problem on the board and say, I don't know, what do I do? Giving them 4 simple steps will help them work through the problem and tell them what they need to do next. When children finish a problem, they need to think about looking back. We need to teach our children to look back. Most of them will look at their paper and say, I looked at it, it's fine, and they did nothing. So let's be intentional. Let's teach them to look back. Look at the problem. Do I actually understand what the problem asked me to do? Look at your answer. Does my answer make sense for what the problem is asking? Does my process make sense? And lastly, examine your own thinking. Question myself, is there another way I can solve this? Is this the best way to solve this? By having our students look back at their work, it's beneficial for them in the bigger process of problem solving and in their mathematical reasoning. So, these are the big ideas to consider when we're thinking about having our children problem solve. We'll discuss this further in class.